have a calculator, you want to get that out because we are going to be doing a lot of checking today, a lot of checking of answers. And I will try to use both Casio and TI. How many Casios do I have in the room? 1, 2, 3. All right. Here we go, ladies and gentlemen. I do want to remind you, I did tell you last week that you'd have a test on Thursday. I'm going to go ahead and just move to Friday. I love you.
Thank you. I really appreciate that.
8:20.
I said I love you. I love you.
All right. So I wrote a review for that, and hopefully I'll have it. But you'll have Wednesday and Thursday in class to work on that review. It turned out to be like 50 questions, which is fairly long, but again, you'll have 2 days to work on it. Anytime you have a review, you are always allowed to take it home, use it to study. Most all the problems come straight out of the book. I'm not that creative. And so you might have seen them already. You might have already done them for homework. You might have done them for extra credit. But here they are put together once again. And that review, you know, I was looking at the test and I wrote the review. So it's a really good review for what you'll probably see on your test. And then if you want, you know, extra problems to help you study for the test, then you would want to find problems similar to those that are on the review. And you can look back at the class website and the photos I took of the pages out of the book. Yes. It'll be due on testing. Yeah. So a review is always due on the day of the test, and you're welcome to take it home. Okay. So today we have lots of different equations that we're solving, sort of wrapping up this solving equations unit where we solve all kinds of different things. And today the rule is check. Check, 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 check. And so we want to find all solutions to the equation. And if you need more assistance or another example, then you can look on example 12 on page A57. Is another example of how to do these things. So find all solutions to the equation. Now I know you probably know how to solve these. But it's important to review these sorts of things, but also just to make sure you know how to check your answer. Because of how these type of equations, these are radical equations because they have a radical in them. Because of the process for solving them, what we actually are doing is we're increasing the degree of the function. And anytime we're increasing a degree of the function, we're increasing the possible number of solutions. And what happens is, well, we've got more solutions than we initially started with, so some of them might be false solutions, and that's pretty much how that happens. So the square root of 2x minus 5, and then subtract 6 equals 0. What do you guys want to do first? Add 6 to the other side. Absolutely. Anytime we have a radical equation, we want to isolate that radical. That is the easy way to solve. So 2x minus 5 equals positive 6, and then what? Square both sides. We are allowed to do that because there is an equal sign, so we can square both sides. The square root and the square cancel out, leaving the 2x minus 5 equals 36. And then we can do what? Add 5. So we get 2x equals 41, and divide by 2. So we get 41 over 2. So this is a possible solution, and I absolutely want to check it just to make sure it's a actual solution, not a false solution. And so the easy thing to do is plug it back in, and you can do this on your Casio or your TI calculator. It's pretty much the same. So I'm just going to take that 41 halves and put it in place of x. So I'm going to do big square root 2, and I'm going to use parentheses, 41 over 2. And then I have subtract 5, and that's under the radical. And then I'm going to subtract 6 on the outside of the radical. If you have a Casio, you want to make sure that you put in parentheses, I think. Let me see. I didn't check this with my Casio. So I'm going to do square root somewhere. There we go. Square root of 2. Okay, so my Casio doesn't have parentheses in that square root. I'm going to put in parentheses just to be sure what is inside the entire radical. 2 times the 41 halves, so 41 over 2. And then subtracting 5. And I'm closing that set of parentheses. So that whole thing is inside parentheses. Sorry, I'm trying to find that sweet spot where you can actually see it. There it is. Okay. And then I'm going to subtract the 6 on the outside. And it's supposed to equal 0. So they both happen to equal 0. So watch those parentheses if you've got the Casio. All right. But plugging it back in, that whole left side is supposed to equal, the right side is supposed to equal 0. So that one absolutely works. So it's a true solution. All right, letter B, what do you want to do? Add the x. Yeah, again, we want to isolate our radical. And so 2x plus 7 equals, what do I have on the right-hand side? Good, x plus 2. And then what should we do? Square both sides. And this is where people make mistakes. The square root squared cancels out, leaving the 2x plus 7. What do you get on the right-hand side?
X plus 4.
Good. X squared plus 4x plus 4. Remember, this is x plus 2 times the quantity x plus 2. You need to write it out 2 times. Fantastic. Make sure you multiply it correctly. We would get x squared plus 2x, which is 4x, and then plus 4. Now, before we had a nice linear equation, this one is quadratic. So how are we going to solve this quadratic equation? Yeah, we want to put everything on one side, set it equal to 0. So I have a positive x squared. I need to subtract the 2x. So 4x minus 2x is 2x. And subtracting 7, 4 minus 7 is negative 3. And then what do you want to do? Factor, double bubble. All right, so we have x times x is x squared. What times what is negative 3? Negative 1 and positive 3. Negative 1 and positive 3. How do you know if you did that correctly? Rainbow. Check the rainbow. And I know I did that correctly because I've already done this. All right, so we get x equals 1 and x equals negative 3 for possible solutions. But we really, really, really need to double check. So I'm going to start by first, do you plug in the 1 for this x and the negative 3 for this x?
No.
No, you plug in the same value everywhere. Okay, just so we're clear. You're testing first, we're going to test that 1. So I'm going to plug in a 1. 2 quantity 1 plus 7 under the radical, and then minus the 1. So just plugging in a 1, and what's it supposed to equal? 2. Yes, it does. So that one absolutely works. And now I want to check that negative 3 as well. So same thing. 2 times the negative 3 plus the 7, and then minus the negative 3. Did that work? No, that was an ultimate fail. That is a false solution. So that can happen. And it happens because this was originally an x to the first power. X to the first power means there's one solution. But by squaring both sides, we created magically this quadratic equation, which would have 2 possible solutions. So we upped the ante. One of them is going to work, and one of them is not. Okay? All right. Questions on that? Okay. Example 2. This is also a radical equation. This is also a radical equation because if you'll remember, this is a rational exponent and it's power over index. So this equation is the square root of x minus 8 quantity cubed. It's another way to write it. But since we just did radical equations, you could solve it that way, or we have a sort of a shortcut we could do. Do you know the shortcut for solving this?
Two-thirds over.
Yeah, 2/3.
2
on
over
both
3.
sides.
Okay. So, yeah, when we have rational exponents, what we're trying to do is we want this to be x minus 8 to the first power. So we want to do something that's going to resolve, shall we say, that 3 over 2. Something that makes it nice. Something that makes it cancel itself out. And that would be taking it to the 2/3 power. So we're going to put, oops, that's supposed to be 2/3. So what happens when I have 3 halves to a power of 2/3? Yeah, why?
Because the numerator and denominator become the same.
Yeah, it's 6 over 6, right? 3 times 2 is 6, 2 times 3 is 6, and 6 over 6 is just 1. So that's the inverse operation, cancels itself out, which is super cool. Now, this 49 to the 2/3 is a little harder to work with. So I have to rewrite that because I'm not that smart. So this is power over index. So this is 49 squared with an index, a root of 3, a cube root, okay? 49 squared is super big. Do I really need to square it, or can I just, I'm trying to break it down, right? All right, so it's 49 times 49. Those break apart too, right? Mm-hmm. It was super fast. All right, and we're looking for 3 of a kind, yeah? So we've got 3 of a kind. What comes out? Mm-hmm. And a cube root of 7 stays underneath. Do you need plus or minus when you do a cube root? Only on even roots. So if we were taking a square root or a fourth root, you'd have to have a plus or minus, but not on cubes, not on odd ones. Okay. Now, how do you get x by itself? Add 8, add 8. Okay. So does that become 15 cube roots of 7? No, it becomes 8 plus 7 cube roots of 7. And I do want to check that answer. And I can. On the Casio, I do see a cube root button. So that's kind of nice. I'm going to take this answer and I'm actually going to go ahead and plug it right back into my original. And so I have, instead of x, I'm going to type in 8 plus 7. Now on my TI, the cube root button is harder to find, but it's there if you know where to look. Under math, on the math menu, you can see there's number 4 is the cube root. So there's the cube root of 7. So there's my x. And then I want to subtract 8. And then I'm going to take it to the 3 halves power. So on the Casio, when you raise it to that 3 halves power, make sure you put it in parentheses. But I have pretty print, and so I don't need to do that on my TI. So that's it plugged in. And lo and behold, it equals 49. Okay. Do we need Casio help here? Okay. So on my Casio, I'm going to do, again with the parentheses, 8 plus 7. My cube root of x button is right down here, and it's a second function. So I'm going to do second cube root. Oh, I wonder if it needs a times. 7, possibly. Yeah, 7 times the cube root of 7. And then subtract 8 to the power. So that's a little caret guy. And I'm going to do, in parentheses, 3 over 2. 49, yay, that worked.
Oh,
3 over 2. Did you do 2/3?
I said, I did 3 over 4 on it.
Oh, okay. Good.
Okay.
Does that work? Okay. All right. Very good. Couple more things here. So really important that you're able to check because I will certainly test that on Friday. All right, absolute value. Absolute value is always a problem. Teaching absolute value, I think it's probably one of the most forgettable things. And too often I hear, oh, my algebra teacher told me to just drop the absolute value. Not how it works. So, absolute value is actually a measure of distance, okay? And geometrically speaking, if I were to walk from here to my desk, that's, I don't know, 20 feet. But if I'm going from my desk to here, isn't it still just 20 feet? We don't use negative numbers to represent distances. That is why absolute value refers to a distance between things, okay? So if I were to read what this actually, the equation is the absolute value of x equals 5, but its meaning is the distance between a number and 0 is 5 units, okay? That's what it means. The distance between a number and 0 is 5 units. And so if I'm thinking about a number line, well, here's 0. Well, what number is a distance of 5 units away? Yeah, 1, 2, 3, 4, 5. Right there, -5 has a distance of 5 units away from 0. What other number has a distance of 5 units? Sure. +5 has a distance of 5 units away from 0. And so whenever we're solving absolute value equations, I need you to go back and think about the real meaning of absolute value, which is the distance away from 0. And how you interpret that is, well, that could be a distance to the left, which would put us in negative land, right? Or it could be a distance to the right of 0, which is positive land, okay? So every time you have an absolute value equation, there must be 2. One that is positive and one that represents that negative distance away. And the way I think about it is, if I try and plug in my solutions, right? The absolute value of -5 is 5. So we know that works. So what happened was the inside could have been negative. And so that's how I sort of write this out. I say the inside of the absolute value, 2x minus 3, could have been negative. And when we simplify, then it pops out as that positive 14. Does that make sense to you? Okay. And then on the other side, it could have just been that regular 5, that positive 5. So the inside could have been just a positive value. Nothing changes in that case. So those are our 2 equations. One that has a negative tacked out in front, and one that's just the original, essentially. I'm going to go ahead and solve this guy. Does that positive do anything? No, it doesn't. It's really just 2x minus 3 equals 14. We can add the 3 and divide by the 2. And we get 17/2 for an answer. So that's the easy, straightforward side. But then we have this negative. There are a couple of things we can do here. What are you thinking of doing? Distribute. That's absolutely an option. You can absolutely distribute the negatives. I can divide by the negative. I'm going to do that. I'm going to divide by the negative because then I don't have quite so much to worry about. You can see how that changed, right? All right, so then I can add the 3, and that gives me -11, and then I can divide by the 2 and get a -11/2. All right, I do want to check these solutions, and I can do that if you know where absolute value is on your calculator. So again, I'm going to plug those in. On the TI, absolute value is under the math menu. So you go to the math menu and you arrow over to number, and ABS, absolute value is the first thing, okay? So you do the absolute value of 2 times my negative 11 halves, and then subtract 3. And what's it supposed to equal? It's supposed to equal 14. And voila, it does. If I check the other one, 2 times the 17 halves, whoops, subtract 3, and again, that also equals 14. So both of these work. On the TI, if you push option is a good button to know on your calculator, option. And then you see this little arrow to the right. So that's F6. So you push F6. And again, same menu. It's the number menu. So if you do the number and ABS, you see it? So
Press
absolute.
to the right and it just gets reversed.
All right. So absolute value of, and again, you're going to want to use parentheses, 2 times the negative 11 halves minus 3, and close those parentheses, and you get 14 there too. Okay. All right. So again, if you need help, I can help you with those. All right. So last one here, a little more complicated. Again, absolute value has 2 possible things that could happen. Either the inside was positive result or the inside was a negative result. And after you simplify it, returns to positive, okay, just because it's an absolute value. So my first equation says, hey, that inside, x squared minus 3x could have been positive. All I'm doing is putting the positive in front of whatever was inside the absolute value. Or that inside stuff, x squared minus 3x, could have been negative. And so that is the only change. What do you want to do with this negative? You could distribute it, or you could divide by -1 everywhere. I'm going to do that. So x squared minus 3x, my negative divided by negative turns to positive. What happens on the right-hand side? Positive 4x and a -6. Those signs are going to change. Now it's quadratic, so I'm going to set everything over to one side. So I get x squared. I'm going to subtract 4x, and a -3x is -7x, and add 6. And I can factor. What times what is +6? -6 and a -1, which means we have possible solutions of 6 or +1. On the right-hand side, that positive, essentially I just solved the equation. Doesn't change anything, but again, I am going to move everything over to one side, which means I'm going to add the 4x. That's going to put me at +1x, and subtract the 6. I love this problem. This is a great problem. All right, so we have x, and what times what is -6? Or +3 and -2. How do you know if you did it right? Check the rainbow, because it'll work. Check the rainbow. All right. So 4 possible solutions here. This one, you'll notice, I'm just going to, for now, and then I'll just give you the answers. I'm going to check x equals 2. So I'm going to plug in everywhere there's an x. And I'm just going to plug in this left-hand side first. So I'm going to do math, absolute value of 2 being squared minus 3 times 2. And I get an answer of 2 on the left-hand side. And I'm going to compare that to what I get on the right-hand side. So negative 4 times 2 plus 6. And that equals negative 2. Did it work? No, that did not balance. 2 is a false solution. Okay. If I trying my negative 3 in the left-hand side, negative 3 being squared minus 3 times negative 3 gives me 18. On the right-hand side, negative 4 times negative 3 is 12, plus 6 is 18. That one works. Okay? And again, if you were to keep checking those other solutions, some are not going to work. Six does not work, but 1 does. So please, please check those answers, ladies and gentlemen. Okay? Do your question 3. All right. You guys can get started on class practice 13.